Hello future engineers, viewers, subscribers, and students. There is another video in statics, particularly on the topic on uh, moment of inertia for built-up sections. So here is the problem. Determine the moment of inertia about the base and about the centroidal y-axis of the built-up steel section, composed of a WT 8 by 50 and 12 inches by 3/4 inches plate, 3/4 inch plate. The properties of the WT section are listed below. So this WT section is actually half of the wide flange. So you reflect it about this axis here, then you'll have the equivalent W section, which is designated as 16 times 2 of this number by, of course, 100 if it is a W section. So these are the properties: area, depth, stem thickness, TW, flange width, BF, as indicated in this guide or in this orientation of the WT section. Then the flange thickness, this is the moment of inertia with respect to the centroidal x-axis of the WT section, 76.8 inches to the fourth, barred Y or YG of the WT section. Distance from the centroidal x-axis to that top edge of the WT section, 1.76, and moment of inertia with respect to the centroidal y-axis is 93.1 inches to the fourth. So here is the problem. So let's determine I centroidal moment of inertia with respect to x and y axis, and your part will be centroidal moment of inertia with respect to the centroidal x-axis to confirm that IGX is indeed the one that I'll be computing here, presenting here. So first, let's have the location of the centroid of the entire built-up section and the corresponding designation, labeling. So that's 1.76. This is YG of the entire section, depth of the WT section. And the reason why this is 1.76 because the orientation is inverted for the WT section. So area is equal to area of the WT section 14.7 plus area of the plate 12 times 3/4 or 12 times 0.75. 12 times 0.75 is 9 plus 14.7, so 23.7 square inches. Next, let's locate the centroid by computing YG by Varignon's theorem. So 23.7 with respect to the base is IGX of the WT section plus area 14.7 distance square is 1.76 plus 0.75 square. That's for with respect to the base for this WT section, which is inverted. Again, it is IGX of the WT section 76.8, then its area is 14.7. We transfer its centroidal moment of inertia with respect to the x to the base because that's parallel, so that's the distance is 1.76 plus 0.75. Then for the rectangular section, the base coincides with the base of the rectangular plate, so it is just 12 3/4 cube over 3 or 12 times 0.75 cube over 3. So computing I sub b equals 171.1 inches to the fourth. Then for IGY, it is the centroidal y-axis coincides to both centroidal axis. So for WT section, there's no need to transfer because the distance is 0. So it is 93.1. For the rectangular plate, it is 12 cube times 0.75 over 12. So IGY is 93.1 for the WT section, IGY, then plus 12 cube 0.75 over 12. So IGY equals 201.1 inches to the fourth. I'll compute IB, I'll compute IGX from the formula IB equals IGX plus area distance square, where the distance is YG in this case. So 23.7 YG, let's locate the centroid first, equals 14.7, then the distance of the centroid of the WT section to the base is 1.76 plus thickness of the rectangular plate 0.75 plus area of the rectangular plate 9, and its distance to the base is centroid. The distance of its centroid to the base is half of 3/4 or 3/8 or 0.375. So computing YG equals 1.6992 inches. So substitute IB equals IGX of the intersection plus area YG square. So area YG square, so 171.1 equals IGX plus 23.7, 1.6992 square. Computing for IGX, 102.67 inches to the fourth. Now, for your part, I want you to solve IGX in another way. This is the other way. You have to transfer, because we have located the centroid of the entire built-up section, and its distance is 1.6992. I want you to transfer the moment of inertia, centroidal moment of inertia of the WT section to that centroidal location of the built-up section by transfer formula. And I want you to transfer the moment of inertia with respect to the centroidal uh, x-axis of the rectangular plate to that axis, and show that IGX is 102.67 inches to the fourth, because that is for your own sake. So determine IGX by another way so that you can master the complete determination of moment of inertia. I just don't want to present solution. I want you to know also, to master the concept. This is my responsibility for my viewers, to make sure that you also learn. If you cannot learn through my presentation, then you may look for another vloggers with this same topic. You might be able to understand them. So that's it. And you just use my problems here for your practice.